Welcome. Today we're diving headfirst into something that sounds super nerdy, but trust me, it's make or break for tons of businesses: industrial steam boilers. Our goal? Uncover the secrets to keeping these beasts humming smoothly without the costly disasters.
And here's the wild part. When you dig through the manuals and case studies, two sneaky villains keep popping up as the culprits behind most major failures. They're quiet, relentless, and always scheming.
Two villains, huh?
Yep, and get this. Your standard boiler warranty almost always excludes damage from both. We're talking hard water and dissolved air.
Whoa, that's a huge gotcha. Okay, let's tackle the first one. Hard water. We know it causes limescale, but what does that actually do inside a high-pressure boiler?
It's pure energy theft. Hard water is loaded with dissolved minerals like calcium and magnesium, heated up to make steam, and those minerals solidify, baking onto the metal surfaces as scale.
Right on the heat transfer surfaces.
Bingo. Scale acts like a blanket of rock, great insulator, terrible conductor. So all the heat from your burners gets stuck in the metal instead of reaching the water.
Meaning the boiler has to crank harder and burn more fuel just to hit the same pressure.
Exactly. You're basically paying to heat a layer of rock.
How fast does that hit the wallet?
Right away. Even a super thin layer, 1/32 of an inch, like a sheet of paper, can drop thermal efficiency by 7 to 10%. That's 7 to 10 cents of every fuel dollar straight down the drain.
Ouch. And it doesn't stop there.
Nope. All that trapped heat creates killer hotspots on the metal. Massive temperature swings stress it out, leading to fatigue, cracks, and eventually a full-blown failure. Scale literally cooks the boiler from the inside.
Cooks the boiler from the inside, that's a vivid way to put it. So what's the fix? Just a filter?
Filters catch solids, but these minerals are dissolved. The only real fix is a proper industrial water softener installed upstream. It strips out the calcium and magnesium from the start.
Got it, clean water and no scale. Now the second villain, dissolved air. Why is it even sneakier?
Because the damage is invisible until boom, catastrophic failure. We're talking oxygen and CO2 dissolved in the feed water. Oxygen and hot water turn super corrosive, drilling deep pits into the metal like tiny acid drills, turning your system into Swiss cheese.
Yikes. And CO2?
CO2 is worse for the pipes. When steam condenses, it forms carbonic acid that slowly eats away at return lines until they're paper thin and spring leaks out of nowhere. It's pitting in the boiler, plus acid erosion in the pipes. Game over.
That Swiss cheese mental image is nightmare fuel. So how do we kick these gases out? The sources mention the Zestos return tank system.
Super clever design. It leans on Henry's law. Gases dissolve less in hotter water. The best way to remove O2 and CO2? Boil it.
So it's a deaerator that boils the water first.
Exactly, an integrated deaerator that also kills thermal shock. Normally, you dump cooler water, around 150 degrees Fahrenheit, into a scorching hot boiler, stressing the welds with constant expansion, contraction. Zestos feeds near boiling water, instead smooth sailing.
Smart. But doesn't boiling take extra energy?
Nope, that's the genius. It recycles waste heat. Returning hot condensate flashes into low-pressure steam that normally gets vented. Zestos captures it to heat the feed water to boiling point. Gases bubble out and vent away, free purification from waste heat.
So it's physics over chemicals, love it. But economically, does it pay off?
Absolutely. Boilers cost hundreds of thousands. Repairs from thermal shock or corrosion? Tens or hundreds of thousands. Plus, insane downtime. Think $10K plus per day. Lost. Avoid one big failure, and it pays for itself many times over. It's pure asset protection.
Makes total sense. One last thing. Boiling hot water is tough on pumps, right? Cavitation?
Spot on. Standard pumps would cavitate and get shredded by steam bubbles. Zestos uses a Grundfos vertical multi-stage centrifugal pump, an industrial champ designed for super hot water, up to 248 degrees Fahrenheit, without those bubbles forming. It's reliable, high pressure, and built for this exact job.
Reassuring. Wrapping up, what are the big takeaways for boiler longevity?
Simple. Stop the two silent killers. Softener for scale and heat-based deaeration, like Zestos, for gases. It's not just about trimming fuel bills, it's protecting your biggest asset from predictable disasters.
Exactly. Efficiency goes way beyond saving a few bucks, it's smart investing, and it makes you think, what waste in your own setup could actually be your hidden gold mine?